Download this code from codegive.com, link in the description below. Using the JSON data type in Google BigQuery, a comprehensive tutorial. Google BigQuery's JSON data type allows you to store and query unstructured or semi-structured data directly within your tables. This is incredibly useful for handling data from APIs, log files, or any situation where the schema might be flexible or not entirely known in advance. This tutorial will cover the basics of the JSON data type, how to load data into it, how to query and extract values, and some advanced techniques. 1. Understanding the JSON data type. The JSON data type in BigQuery is designed to store valid JSON documents. These documents can be simple key-value pairs, nested objects, arrays of values, or any combination thereof. BigQuery automatically parses and indexes the JSON data, allowing for efficient querying. Key advantages of using JSON in BigQuery **** schema flexibility ** no need to predefine all the fields in your data. You can add or change fields in your JSON objects without altering the table schema. * handling complex data structures * easily store and query nested objects and arrays within your data. * integration with APIs and log files * seamlessly ingest data from APIs that return JSON and log files with varying formats. * semi-structured data management * effectively manage data that doesn't strictly conform to a fixed, relational schema. 2. Creating a table with a JSON column. Let's start by creating a table with a column that uses the JSON data type. We'll use the Google Cloud Console or the BQ command line tool. Using the Google Cloud Console * 1. Go to the BigQuery page in the Google Cloud Console. 2. Select your project and dataset. 3. Click Create Table. 4. In the Create Table dialog, configure the table as follows. *source *empty table. *dataset name *your dataset name. *table name *products. *schema click Edit as text and paste the following schema definition. *table type native table. 5. Click Create Table. Using the BQ command line tool *. First, create a JSON file, example schema.json, with the table schema. Then, use the BQ command. Replace your project ID and your _dataset with your actual project and dataset names. In this example, the products table has two columns. *ID, an integer identifier for each product, required. *product_details, a JSON column that will store details about the product, nullable, meaning it can be empty. 3. Loading data into the JSON column. BigQuery supports several methods for loading data, including CSV, JSON, Avro, Parquet, and ORC. When loading into a JSON column, you typically use the JSON or CSV formats. Let's demonstrate using the JSON format. Example JSON data, products.json. Loading data using the Google Cloud Console *. 1. Go to the BigQuery page in the Google Cloud Console. 2. Select your dataset and the products table. 3. Click Add Data and select Upload File from Computer. 4. In the Create Table from dialog. *source *upload. *create table from *upload. *select file *browse and select the products.json file. *file format *JSON. *table name *products, verify. *write preference *write if empty /append to table, depending on your needs. Asterisk auto detect schema asterisk should be detected from the schema we already set up, disable if needed. Asterisk number of errors allowed asterisk 0, or your desired tolerance. 5. Click Create. Loading data using the BQ command line tool asterisk. Asterisk dash source underscore format equals new line underscore delimited underscore JSON, specifies that the file is a JSON file where each line represents a separate JSON object. Asterisk your project ID your underscore dataset.products, the fully qualified name of your BigQuery table. Asterisk products.json, the path to your JSON file. Asterisk ID integer product underscore details JSON, explicitly defines the data types of the columns being loaded from the JSON file. This ensures BigQuery correctly interprets the data. If you omitted this, it would attempt to auto-detect types, which might lead to unexpected results. 4. Querying and extracting data from the JSON column. The power of the JSON data type lies in its ability to be queried directly. BigQuery provides special functions to extract values from JSON objects. Basic querying with JSON underscore value and JSON underscore query asterisk. Asterisk JSON underscore value, JSON underscore expression, JSON underscore path, asterisk extracts a single value, scalar value, from a JSON object based on the provided JSON underscore path. The result is returned as a string. This function is best suited for extracting string, numeric, or Boolean values. Asterisk JSON underscore query, JSON underscore expression, JSON underscore path, asterisk extracts a JSON fragment, an object or an array, from a JSON object based on the provided JSON underscore path. The result is returned as a JSON object. This is suitable when you need to extract nested structures. JSON path syntax asterisk. The JSON underscore path argument uses JSON path syntax, which is similar to XPath for XML. Here are some common JSON path expressions. Asterisk $.name, selects the value of the name field in the root JSON object. Asterisk $.specs.cpu, selects the value of the CPU field within the specs object. Asterisk $.specsOS, selects the value of the OS field within the specs object. Useful when the field name contains special characters. Asterisk $0, selects the first element of a JSON array, arrays are zero indexed. Example queries asterisk. This query retrieves the ID and the name of each product from the product underscore details JSON column. JSON underscore value, product underscore details, $.name, extracts the value of the name field. The as product underscore name aliases the extracted value to a more readable column name. This query demonstrates extracting a numeric value and using it in a where clause. Since JSON underscore value always returns a string, we need to cast the extracted price to a numeric type, using cast as numeric. This query extracts the entire specs object as a JSON object using JSON underscore query. The result will be a JSON value containing the nested specifications. This is useful for further processing or storing the specifications in another table. This query demonstrates nested extraction. First JSON underscore query, product underscore details, $.specs, retrieves the specs object as JSON. Then JSON underscore value extract the OS value from the result of the JSON underscore query. 5. Handling arrays within JSON. JSON data often contains arrays of values. BigQuery provides functions and techniques to work with these arrays. Example JSON data with arrays, products with tags.json. Load this data into the products table, using the same bqload command as before, but point it to products with tags.json. Note, we can load this data without changing the schema as the product details column already exists as JSON. Querying arrays with JSON value array and JSON query array asterisk. These functions behave much like JSON value and JSON query but are specifically designed to return arrays. These functions do not exist. Instead, you can use JSON extract array instead of these two functions. Asterisk JSON extract array, JSON expression, JSON path, asterisk extracts a JSON array as a BQ array. Example query asterisk. This query retrieves the ID and the tags for each product. JSON extract array extracts the array of tags from product details. The where clause filters for products where the tags field exists and is not null. To access individual elements within the array, you would typically unnest the array. This query retrieves the ID and each individual tag for each product. The unnest function expands the array of tags into separate rows, allowing you to treat each tag as a distinct value. The where clause filters for rows where the tags array is not null, preventing errors when unnesting. 6. Working with save prefix for error handling. If a JSON path is invalid or the expected field doesn't exist, BigQuery can return an error. To handle these cases gracefully, you can use the save prefix with the JSON value and JSON query functions. Example asterisk. If the non-existent field doesn't exist in the product details JSON, save.json value will return null instead of throwing an error. This allows your query to continue processing even if some JSON documents are missing certain fields. 7. Advanced techniques. Asterisk using with clause for complex extract ions asterisk. When you need to perform multiple extract ions from the same JSON object, using a with clause can improve readability and performance. This query first extracts the product name, price, and specifications into a temporary table product details. Then, it selects from this temporary table and accesses the CPU specification, making the query more organized and easier to understand. Asterisk dynamic JSON path construction asterisk. While generally not recommended for performance reasons, you can construct JSON paths dynamically using string concatenation, particularly if the path is based on data within the table. In this example, the JSON path is constructed by concatenating the string $$ with the value from the name field. This is a simplified example, but it illustrates the general principle. Use this with caution as it can hinder query optimization. Asterisk combining JSON with other data types asterisk. The true power of JSON in BigQuery comes from combining it with other data types. You can join tables based on values extracted from JSON columns, filter based on conditions involving both JSON and non-JSON columns, and aggregate data across JSON and non-JSON fields. 8. Considerations and best practices. Asterisk performance asterisk extensive use of JSON value and JSON query can impact query performance, especially on large data sets. Consider these optimizations. Asterisk denormalization asterisk if specific fields are frequently queried, consider adding them as dedicated columns to your table to avoid repeated JSON parsing. Asterisk materialized views asterisk for complex queries that are run repeatedly, use materialized views to pre-compute the results and improve query performance. Asterisk partitioning and clustering. Asterisk partition and cluster your tables based on frequently queried fields to reduce the amount of data scanned. Asterisk data validation. Asterisk ensure your JSON data is valid before loading it into BigQuery. Invalid JSON can cause errors and unexpected results. Asterisk schema evolution. Asterisk be mindful of schema evolution. Adding new fields to your JSON objects will not break existing queries, but you may need to update your queries to take advantage of the new fields. Asterisk JSON size limits. Asterisk be aware of BigQuery's size limits for individual JSON documents. Larger than 20 megabytes JSON documents are not recommended. Asterisk JSON versus nested/repeated fields. Asterisk consider whether the JSON data type is truly the best choice. For data with a relatively fixed schema but with some repetition, example an array of addresses, nested and repeated fields may provide better performance and type safety. JSON is ideal for truly schemaless or highly variable data. In summary, asterisk. The JSON data type in BigQuery provides a flexible and powerful way to store and query semi-structured data. By mastering the functions and techniques outlined in this tutorial, you can effectively manage JSON data in your BigQuery datasets, extract valuable insights, and integrate your data with external sources. Remember to consider the trade-offs between flexibility and performance and to optimize your queries for large data sets. Good luck.